So the first component we're going to create is a through-hole component. I've chosen to create the P-channel power MOSFET FQP17P10, and this is a high current MOSFET that is typically used in a H-bridge design if you're going to be controlling a motor or a high current output. And so it has a TO220 footprint, which is a very standard transistor footprint, and you also see some voltage regulators use the same footprint. So we'll be creating the schematic component for a MOSFET, a P-channel MOSFET, and then we'll be creating the PCB layout for a TO220 footprint, which is very common and a good place to start. So typically before I get started creating a component, you need some information first. So find the datasheet for your component that you want to create, and there's two things that you want to look for. The very first thing will help you design the schematic, and it is the pinout, so which pins are which, and of course an application circuit, so you can see how the best way to wire up the schematic drawing of the component is. So those two things are outlined in the top image here. On the left we have our pinout. We know that if the TO220 device is laying on its back, it will be gate, drain, and source from left to right facing the transistor. And the application circuit, of course, for a MOSFET is the schematic drawing for a MOSFET, as shown here, which we're very comfortable with. Sometimes you'll see more complex components simply in a black box shape, where the pins are named as inputs and outputs on the left or right of the box. So for this one, it's a bit more specific, and we'll be creating this exact MOSFET outline. So the second thing is when you're actually designing the footprint and you need to know the physical dimensions of where those pins will be placed in the PCB component. And typically that is found in the bottom of the datasheet. So to show you where these are found in the datasheet, I thought I would bring up the datasheet. So let's go to my documents. So the pinout and application circuit are typically shown at the first or second page. In this case, the very first page shows our transistor outline and the schematic symbol. So the symbol is what you're going to be drawing in your schematic editor, and we need to align the pins in that schematic editor to the physical positions shown in the PCB document. So the pinout is very important. And the actual PCB drawings you'll usually find at the very bottom of the datasheet. So all the way down here, you'll usually find your physical dimensions. And be sure to note whether they're in millimeters or imperial units, and we'll need to extract some information of this when we're creating the PCB footprint. So let's get started. We've got the information we need. The first place to start is to create the component schematic. So as we mentioned, we'll be using the pinout and application circuit to plan our drawing, and then we'll just be placing lines and shapes to actually draw that MOSFET shape, and finally we'll place pins for each component connection that we need to describe. So where we left off earlier, this is my empty schematic library, bar this one component, which is a empty component created by Altium. So let's edit this and let's set up the attributes for our component. So our designators, remember, are a prefix to designate different components in your circuit. Resistors are integrated chips, U, and MOSFETs are typically denoted by Q, and then a number indicating its position within the schematic. So to get that number denoted, typically for your component, you will use a question mark as a suffix. So your designator prefix Q followed by a question mark is the typical designator for a MOSFET. If it was a resistor, it would be R question mark, and so on. So Q question mark, we want to make sure it's visible. And our comment, so usually you see comments are the actual part number for your device. In our case, it was FQP17P10. The description, so we can be as descriptive as you like here. Typically it's better to be more descriptive so that the users of your library know exactly what they're getting. So we're looking at a P-channel power MOSFET. So an important thing is the actual name of your component, and it's the symbol reference, and we're going to name that the part number as well, FQP17P10. There are some other options here. So you have some options to have hidden pins and things of that nature, and this is typically where you would also link your schematic component to its PCB component. So our TO220 outline will also be something we add here, but we haven't created it yet, so we're just going to leave the rest of this blank for now. So we've set up the information for our component. Now we can begin actually drawing our device onto there. So before I start drawing, I'll need to set up the grid so that I can set the precision of how I'm going to be placing my lines and components onto this board. We will go to Tools and Document Options. So we can first look at the units. Now, a quick note on these units. By default, Altium uses imperial units for all your schematic design. I would not change this because if one schematic component uses metric and another uses imperial, there's a chance that their pins won't line up when you're trying to make a drawing, and then those pins won't be maintained in the PCB, and you may have unconnected, undesirable pins. So leave the units as normal, but you may want to change the grid size. So I'd rather use a smaller grid size, perhaps 1, to allow me to get some intricate detail on my MOSFET drawings. So now let's begin placing lines and shapes to construct our MOSFET outline. Every tool you'll access is under the Place drop-down menu, and I'm going to start by drawing the center lines of our MOSFET. So let's place them basically 3 in, and we'll start with a full line. So I typically use the default line values in terms of line width and color that Altium requires, because most often other components will follow those same line widths and things of that nature. Now let's place the right hand side dashed line indicating the source and drain. So that's our inner lines of the MOSFET. And now let's draw up the source line. So the source line comes from up here, and we'll try and keep this within a rough square. So I'll place another line, and we can connect up the drain. And our drain will go to there. And now let's draw up the gate. So the gate line will lead out to here. So we're starting to have our MOSFET take shape. The next thing I might want to draw is indicating whether it's an N channel or P channel FET. So remember, P channel, the arrow on the drain will tell it that it's pointing out of the transistor. So our arrow will be pointing to the right in this case. So to place an arrow component, I would use the polygon tool. Place polygon. And I'm just going to do a small triangle polygon like so. Press escape, that'll cancel it. So our MOSFET is coming together now. So at this point, so the final shape drawing here would be the circle around the outside of the MOSFET. So to place that, you want to just place a full circle. And for the circle, you can designate the radius and the center coordinates. So we're going to center it right at the middle, and we may place it just enough outside there. So there's our P-channel MOSFET schematic drawing, but you may notice there are some important things missing. And let's go back to our steps. So the final step is to place a pin, which is a specific type of object that you place in a schematic for every single component connection. So for a MOSFET, there are 3 pins: the source, the gate, and the drain. We need to create these pins, give them a designator, and we'll show you how to do that right now. So now we need to place the pins. So you go to the Place drop-down menu, and you're looking at the second item, Pin. So this is a pin that you'll be placing, and they're very important parts of your schematic. You need to have every single pin that the component requires created in your schematic. So I can press spacebar to rotate the pin. You'll notice that there is one side of the pin that has a crosshair and the other side is blank. The crosshair indicates where you'll be able to connect wire to this pin. So typically that crosshair has to be on the outside of your component. You'll also notice 2 comments here. We have a 1 on top of the pin and a 1 on the other side of the pin. Press Tab to bring up the pin properties, and you'll typically want to modify those components. So the two things you wish to modify are the display name and the designator. So the display name typically describes the component pin's purpose. So in the case of our MOSFET, we have a gate, drain, and a source. So our first pin is our gate, and I'm going to give that the display name G. And it is our first pin. Typically, you'll see the designator simply be an integer, counting up from 1 to 2 to 3 for however many pins there are in your design. And eventually, you'll be using the pin designator to match up to your PCB pin names. So it's very important that you have them named correctly. So I'll go gate is pin 1, and I'll place that pin conveniently there with the crosshair on the outside. One little thing you'll notice in this case is that my pin name G is kind of interfering with the drawing of my schematic. So in some cases you may want to hide the pin name. So double click your pin and check off visibility in the very first option there, because for this transistor we can already discern what is a gate via its placement in the schematic drawing. One thing that's important to note is you get the pin name and the pin designators matched up correctly, as in which pin is pin 1, pin 2, and pin 3. So let's go back to our datasheet for a second, and we want to look at the application circuit and the pin out. So this is the pin out and the application drawing. We're going to be giving it a pin designator. We need to make sure that that pin designator, in this case 1, will match up to our labeling of the pins in the PCB. So for now, I'm going to label them 1, 2, 3 for gate, drain, and then source. So that will be our naming convention. You have to define your own naming convention and make sure that you don't get pins mixed up. So we'll go back to Altium. So 1 will be my gate, 2 will be my drain, and 3 will be the source with the arrow. So let's place our other pins. Place pin, and you'll notice because my component numbering was 1, 1, every time I add an additional component, Altium will automatically increment our display name. So I press Tab to modify the display name. I want it to be my drain, and it will be non-visible. And you also have some options here to change the length of the pin, its orientation, and several other features which are useful. So I need to press spacebar to rotate, and I want the crosshair on the outside, and this will be placed just like so. Altium automatically allows me to place number 3, but I need to change its display name, so press Tab. And the display name now will be S for source. It's also not visible, and we need to rotate this to get the crosshair on the outside. So there you have it. There's our completed schematic component. We have the gate, drain, and the source. You can see your pin information in the third window on the left. We know that pin 1 is the gate, pin 2 is the drain, and pin 3 is the source. We also need to make sure that this is achieved in our PCB drawing. So to design the PCB footprint, we need to open our PCB library. We're in the PCB library editor. And the first step to create your component footprint is to use the footprint drawing and dimensions to plan what your layout is going to look like. So let's have a look at our datasheet. So again, the footprint drawings are usually right down the bottom. You're looking for some dimensions. And the drawing on the left here is what we really want to focus on, particularly the legs, because what you're doing, the only thing that matters for a through-hole component essentially is that you have holes of the right size and spacing that the component legs can fit into the holes and be soldered. So these legs are the important things that we need to look at. And if you look closely, you'll see that the spacing between each of the pins is 2.54 millimeters. This is a standard pitch, and it is translated to 100 mils in the imperial system. So the other thing to be aware of is the width of the pin legs, because they will determine what the diameter of our through holes is. So this inner width here is 0.38 millimeters to 1.02 millimeters. So we need a hole that can hold at least, right around 1.02 millimeters. So the convention for the TO220 transistor standard is right around 40 mils in imperial units, which translates to roughly 1.02 millimeters. So we'll be using pitch spacing of 100 mils and a hole diameter of 40 mils. because that conforms to this pin spacing for the TO220 component. So the second step after planning your layout is to start placing through-hole pads onto your component. So let's have a go at that in Altium. So here's my blank PCB library with a single empty component. Let's start by modifying this component. So double-click the component, and you'll give it a component name. In this case, we'll be using the TO220. By not being specific to our MOSFET, we're able to use this footprint for regulators, any other MOSFET that conforms to that same footprint. And the description, well, it's just a transistor outline 220. We're quite obvious with that. And the height is kind of useful in Altium if you're doing 3D construction of what the PCB will look like. That's kind of beyond the scope of this, so we'll just select OK with a 0 height. So we created our empty component. Now we can begin placing our through holes. So typically you want to place these through holes centered to the origin, so that whenever you move your PCB around, it's always centered about the mouse point. So let's place our through holes by selecting place, and you're looking for pad. So surface mount pads and through hole pads, they're all added through the same menu in Altium, and I'll show you how to use surface mount pads later, but by default we have our through hole pad. So before placing, press Tab to modify the pad properties. So there's a variety of properties here to take note of. What we want to do first of all is get the hole size correct. So the hole size here is what the transistor legs will actually be fitting through. So it's the diameter of the hole on the board. And we chose 40 mils because that's the TO220 standard. You can also specify its location programmatically. You can change whether you want a round or rectangular or a slot hole. In our case, we just want a simple round hole. And then you have the properties menu. So the designator for this pad needs to match up to the designator in your schematic. So if we're going to be placing the through hole for the gate pin, it needs to be designator 1. The next option here is the layer drop-down menu. And this allows you to select whether you're using a surface mount component or a through-hole component, because the through-hole component requires multiple drawings on multiple layers, whereas a surface mount component only requires top layer soldering. So in our case, we need to make sure multi-layer is selected for a through-hole component. We're not connecting a net or anything like that. We're leaving the pin open for other connections. And that's typically all you want to modify. So we press OK. Now we need to make sure that our gate pin is actually in the correct orientation. Is it on the left, is it in the middle, or is it in the right? So I know from looking at our drawing earlier that the gate pin is the leftmost pin when the transistor was lying on its back. And we need a pitch spacing of 100 mils. So when I'm placing this, I want to look at the XY coordinates at the very bottom left of Altium. And I want to place this on the origin, but 100 mils to the left. So right about there. So there's my pin 1. Now pin 2 is our drain, and I need to place that at the origin. Then finally pin 3, which is 100 mils to the right. So an often useful feature when you're designing your own component is to help people who are soldering your board by letting them know which pin is pin 1 for various components. There are several ways to do this. Sometimes you accomplish it by placing a small dot near the pin. A better way is to actually change it from having a circular hole to a square hole, because they can be easily milled as well. So let's do that for pin 1. So rather than having a round hole, we need to change it to a rectangular one. And notice that it didn't also change the size and the shape of our solder mask layer. So we need to change that, and we do that with the right hand option here, and also change it to a rectangular shape. So press OK. And now we have our pin 1, which is a square hole, and the other two pins, 2 and 3. So now we can easily identify which is our gate. Essentially, we've finished. I mean, ultimately, a component can be placed into those through holes, and our component is functional. But we want to make it nice and neat so that there's less confusion when you're soldering components. And one thing to do is to place a component outline. So roughly the rectangular size and shape of your component, draw that in on the board in the top overlay or silkscreen layer so it's easily identifiable which component is which. So in Altium, what we want to do is draw the transistor outline. So we need to know what is the length and width of the transistor. So we need to go to our datasheet, and we want the length of the component, which looks to be between 9.6 millimeters and 10.6 millimeters. So let's choose 10 millimeters. And then we want to get the width of the component, which appears to be between 3.5 millimeters and 4.8 millimeters. So let's choose 4.5 millimeters. So we can go place, and what you're looking for here is just a line. However, before you place this line, you'll notice that the layer that you're writing on needs to be chosen. So if I began writing now, it's actually drawing copper on the top layer of the component. And that's not what we want. You don't want the outline being in the top copper. Instead, we want it to appear on the silkscreen layer. So what you'll do is press the yellow layer named top overlay. And now you can begin placing the transistor outline. So a quick way to change the units while I'm placing this transistor outline is to go to View, Toggle Units. So we're in millimeters now if you look at the X and Y coordinates at the bottom left. And we need roughly a 10 millimeter wide, 4.5 millimeter tall rectangle that we'll be drawing here. So go to Place, Line. So I want to go roughly -5 in the X coordinate and about -2 and a bit in the Y coordinate. So I went to there, straight up, and across to -5 on the other side. There's my transistor outline. One more thing that will be useful is to indicate where the heatsink attachment is on the transistor so that you can get the correct orientation. So remember, pin 1 is on the left when you're facing it, and in that case the heatsink is on the back of the device. So this tells us that if I'm going back to Altium, I need to draw a single line to indicate where the heatsink is, just like so. That will suffice. So that's the correct outline. There's my heatsink back, and the gate and pin 1 is on the left side of the component. So I'll save that, and there we have it. That's our PCB component. The final step is to link your PCB component to your schematic component and ensure that the pins are pointing to the right ones. So let's go through and do that. So to do this, you'll be going back to your schematic library, and what you need to do is to go to the Models window, which is the 4th window down on the left pane, and select Add, this button. And we wish to add a footprint. So press OK, and this is our menu to add a footprint. You'll just want to browse. Altium recognizes that you have a PCB library open, and it will automatically pull that up. But if you want to grab it from a different library, you can. But for now, it's just recognized the component that we just created, and you select OK. And you have a nice drawing of the footprint. You can see that it matches up. Press OK. And now it's actually mapped pin designator in the schematic to the pin designator on the PCB, and we can match them up here. So you can see pin 1 of the TO220 is lined up with pin 1 on the schematic, and so on and so forth for pin 2 and 3. So because we followed the datasheet to a T, we know that our pins are around the right way. It's a very important step, and you'll want to double check by verifying the datasheet, your PCB, and your schematic component. So now our components are linked. We can save all of our work, and if we were to compile our library at this point, we will have a fresh component that exists inside of it that we can use. So let's do that. Let's compile our freshly created integrated library via right-clicking, selecting Compile. And it happened quite quickly, and it automatically installs in Altium my integrated library, and we have our FQP component as shown here. There's the schematic that we created and the footprint that we linked it to. So that completes this screencast on creating a through-hole component. The next screencast will look at creating a surface mount component.